Next, we're going to talk about chemical reactions. So our body has to undergo chemical reactions all the time, where we're going to either build molecules by bonding atoms together, or we're going to take a molecule and rip it apart and break those bonds to release energy or to do some other kind of process. Now, Handout 2E is going to discuss chemical reactions. When you think of chemical reactions, think of all of those chemical processes that are going on in your body to perform some kind of function. Now, when this occurs, we have a word for it. It's called metabolism. So metabolism is all your chemical reactions. Now, there are two kinds of chemical reactions: anabolic and catabolic reactions. This is really easy. Catabolic reactions, or catabolism, are going to break stuff apart. So digestion, for example, when you are eating something, let's say you eat an apple, you are going to break that apple down. That's called catabolism. So if we break it down, we are undergoing a type of metabolism called catabolism. We also can call catabolism a decomposition reaction because we're destroying something, it's decomposing. The other type of chemical reaction is called anabolism. Anabolism are where we're going to build things. So growth of tissue, maintenance, repair, all of these body functions are going to require anabolism, where we're going to add and build molecules. This is also called a synthesis reaction. But what happens is we're going to build a molecule, such as muscle proteins if we're working out. We can repair any damage. Our hair, our skin is continuously growing. So all of those things are known as anabolism. If we take all of the anabolic stuff that our body does and all of the catabolic stuff our body does, we put it together, that's where we say we have metabolism. So metabolism is all those chemical reactions. Now, as I go through this handout, I just have some examples of both anabolism and catabolism. So let's just look at this first example. This says it's a synthesis reaction, so that's anabolism. We're going to take, for example, these separate amino acids, and we're going to build a long chain of amino acids. So we're building something here, and that's just an example of anabolism. The example underneath it is going to be a catabolic reaction, where we have this long carbohydrate chain, and we're going to break it apart into separate carbohydrate pieces. And so we can take that carbohydrate and we can break it down into glucose. Now, our body is going to be performing all chemical reactions at 98.6 degrees. But in general, if we were in the chemistry lab, it would take hundreds and hundreds of degrees to cause some kind of chemical reaction. So for example, to take this carbohydrate molecule and to break it into separate glucoses, if we did that in the lab, it would take hundreds of degrees. This is what we call the activation energy. The activation energy is going to be the minimum required energy to cause a chemical reaction. So in order for me to take this carbohydrate and break it into separate glucoses, I'm going to need a certain amount of energy added to that molecule. Now, under normal circumstances, the temperatures that we would need to do this are going to be way too high for our body. We're talking hundreds and hundreds of degrees, but our body operates at 98.6 degrees. And the way our body can cause these chemical reactions is due to a protein or a set of proteins called enzymes. So what enzymes do, it says they're proteins in our body that lower our activation energy. So if we have a enzyme, this enzyme will cause the chemical reaction to occur at 98.6 degrees. So we can take this carbohydrate, we can break it down into separate glucose molecules at 98.6 degrees because we have an enzyme that can be activated to cause that chemical reaction. Now, here at the bottom, all I have here is just a little tip. Usually enzymes will end in the prefix ASE. So I'll give you an example here. I don't want to write on my handout, but there's an enzyme called lactase. See, that ends in ASE. Lactase is an enzyme that breaks down lactose sugar. So lactose sugar is something that we eat. It's in dairy products. You know, lactose is in milk. It's in ice cream. It's in yogurt. And when we eat it, we have this lactose sugar. This lactose sugar is then broken down by this enzyme called lactase. And we can break down that lactose sugar into smaller pieces. Now, you've probably heard, or maybe you even are, lactose intolerant. If you are lactose intolerant, you don't have this lactase enzyme. This lactase enzyme is missing, or you don't have enough of it to break down the lactose. So when you eat lactose, like if you drink milk or if you eat ice cream, that lactose is going to go into your digestive system, but it's not going to get broken down because you're missing the enzyme lactase. So that lactose molecule just sits in your intestines, and it can become unpleasant. You know, you can get kind of sick to your stomach, get gas, bloating. And that's because the bacteria in your intestines will start to metabolize this lactose on their own, and it can cause discomfort, lots of gas, bloating, feeling sick to your stomach. There is a remedy to that. They actually sell lactase enzyme. You can go to Rite Aid or your local grocery store and pick up some pills of lactase enzyme. If you take those pills of lactase prior to eating your ice cream, then you will have that enzyme to break down the lactose, and then you won't have all that discomfort. So this is an example of metabolism. And so remember that all your chemical reactions in your body equal metabolism. We have two kinds, catabolism and anabolism, where we break stuff down through catabolism and we build new molecules through anabolism. So our body is always undergoing lots of chemical reactions, and that is what we call metabolism. All right, I'll see you for the next video.